Hi, everybody. Mrs. Bixler here, and we are still doing our introduction to geometry. Lots of stuff in here, and we're going to continue to talk about all of our justifications and more with proofs. So, remind me here when we talked about this flow the other day about a linear pair to sup pos to def sup. I want you to pause the video right here and tell me what each one of these is. Okay, we're back. So I know I said tell me, but tell yourself. So remember, the definition of a linear pair is all it is a straight line that then we broke up into two adjacent angles, and they make up a straight line. So two angles that make up a straight line are a linear pair. Suppost is then if I see that it's a linear pair, then I know that the linear pair are supplementary to each other. So I know angle 1 is sup to angle 2. That's the suppost. And then def sup would be that the measurement of angle 1 plus the measurement of angle 2 equals 180 degrees. So I just want to make sure that we feel good about that flow. All right, so running a little bit more with supplementary angles. So remember, supplementary angles are two angles that add up to 180 degrees. Complementary angles are going to be two angles that add up to 90 degrees. And just like supplementary angles, they can be adjacent. And if they are adjacent to each other, I know that complementary angles are going to be within a right angle. So like angle 1 and angle 2 would be considered complementary angles. But I also could have a random angle like this, angle 3 and angle 4, and see how they're not adjacent. Totally fine. If they add up to 90 degrees, if one is 10 and one is 80, they're complementary angles and they're complements of each other. So we know that we have the suppost. So the suppost tells us I've got a linear pair here, and I know that angle 1 and angle 2 are going to be supplementary to each other. Pause the video and think about what on earth the compost or the complementary postulate could be. Okay, we're back. So remember, I said that complementary angles are two angles that add up to 90. And I said if you have a right angle and you've got two angles that make up that right angle, then you know that they're going to add up to 90. So I've got angle 1 and angle 2 here. And in this case, I know angle 1 and angle 2 are complementary to each other because they make up a right angle. That's the compost. All right, so some other important things here. So we added in today complementary angles and compost. Now we're going to add in the definition of congruence, and this is also known as DEF-CONG. So the definition of congruence is just two line segments or two angles that are congruent to each other. Their measurements are equal. So if I am told that line segment AM is congruent to line segment MB, then I know that the measurement of AM is equal to the measurement of MB. And remember, measurement means no line on top. Same thing with the angles. So if I'm told that angle 1 is congruent to angle 2, then I know that the measurement of angle 1 is equal to the measurement of angle 2. Good? All right, moving on. So now we've got three other properties. So now we've covered a lot of stuff. We've got complementary angles, we've got compost, and then we just talked about DEF-CONG. So now we're adding on. So these are three important properties. The big mamas are going to be the reflexive and the transitive property. Substitution we'll use, I'll give this like a half star. Substitution we'll use, but not all the time. So reflexive is big. We will use reflexive whenever we want to introduce something into our proof. So whenever we're saying like, oh, I'm going to add in like angle 1, I just want to start talking about angle 1, you have to use the reflexive property first. So the reflexive property is super simple. Angle 1 is congruent to angle 1. Line segment AB is congruent to line segment of AB. You're done. Now the transitive property, we talked about transitivity with logic, and now we can talk about transitivity in terms of equality or congruence. So if I know that A is equal to B and B is equal to C, then I know that A is equal to C. We'll talk about transitivity being a train. And that's when I can think of my conductor and I think of my caboose, and they live together on their choo-choo train. Whoop, whoop. So that is how you can think about the transitive property. And we'll see that in motion in a little bit. And then the last one's substitution. So you saw substitution last year in algebra, but this is just when I have a statement like 3x plus 2y equals 10, but I'm also told that y equals 4x. If I substitute in 4x for y, that's the substitution property. And again, we will see this in our proofs. It comes up rarely, but it does come up. It feels sometimes like it's transitivity when it's going to be substitution. All right, moving on. So this is super quick. These are big properties. The addition property and the subtraction property of equality we're going to use a lot. Multiplication and division we'll see kind of on harder proofs, but for right now, addition and subtraction we'll see a lot. So if we were to solve this equation, the first thing I would do is I would get my x's together. So I'd subtract 3x from one side and I'd subtract 3x from the other. That subtraction from one side to the other is called the subtraction property of equality. And sometimes we abbreviate it as just minus of equals. And so then I'm left with 1x minus 8 equals 10. And then I'm going to add 8 to one side and then add 8 to the other side. So I've got two things that are equal to each other. They're still going to be equal to each other, even though I just added the same thing on to both. So we call this the addition property of equality. And then I'm left with 1x is equal to 18. And then you're done. You know, you could say that like, okay, I'm going to divide by 1, divide by 1. That would be the division property of equality, although we know, you know, dividing by 1 doesn't really do anything. But that's where the addition, subtraction, multiplication, division properties come in. And so again, we'll see this kind of in a proof in a second. All right, so here is a little conundrum. There's GCDS, woohoo! So I am given that GC, this chunk, is congruent to line segment DS. And I want to prove that the bigger guys are congruent to each other. So in class, we're going to talk this out. But I want you to pause the video right now and think about how you could prove that those two bigger line segments are going to be congruent to each other. All right, we're back. So hopefully you felt like, okay, we're starting small, we're going to get bigger. So maybe we're going to add things on. So there's a lot sort of that you could think about with this kind of problem. And we're going to organize our thoughts into what we call a two-column proof. And so in our two-column proofs, we're going to be given a set of information. So in the case before, it was that the two line segments are congruent. And then we're going to be told to prove a certain set of information. And here's what's cool about proofs. 99% of the time, your very first statement is going to be your given statement. And the reason why you're allowed to say that is because it's given. 100% of the time, your last statement, and it could be the 5th step, it could be the 17th step, 100% of the time, your last statement is going to be what they've asked you to prove. And we don't know actually what that reason is here, and we have to fill that in. And what goes in this whole column are all of those justifications we've talked about. So sup post, sup theorem, the angle addition postulate, the segment addition postulate, some of those like definition of supplementary angles. All of these kinds of reasons that we've talked about go in the right-hand column. So this is just something to keep in mind with these proofs as we build them together. All right, so let's look at a proof together here, and we're going to kind of fly through this because I don't want to bore you. All right, so we are given a set of information. We are given that angle BAD is congruent to angle CAT, and you want to think about this given as a gift. It's a wonderful little present. Look at how cute it is, tied up with a bow. This is a huge present. This is giving us a lot of information, and the reason why we're allowed to say that these two guys are congruent to each other is because it's given to us. So that's all we have to write in this first step. And I know ultimately that I'm trying to prove that these bigger angles are congruent. So angle BAT is congruent to angle CAD. So this big mama is congruent to this big mama, okay? So that's kind of where our brain needs to go. We're starting small, we're getting bigger. So let's look at the next statement here. My next statement is that angle 2 is congruent to angle 2. Why do you think I can say that angle 2 and angle 2 are congruent to each other? It's the reflexive, exactly. So we've got the reflexive property. So whenever I have two things that are congruent to each other, it's going to be the reflexive property. All right, let's add on to this. Now, one little step that we've got to talk about here is we were able to say that angle BAD, so this guy plus angle 2, see that green little arrow? That's going to be equal to CAT plus 2. Do you know why? Look, I've got BAD congruent to CAT. If I add 2 onto both of them, that is going to be the addition property of equality. And in fact, we skipped a step here that's going to be really important. We need to make sure that we switch from angle BAD being congruent to angle CAT. We need to make sure that we switch to angle BAD being equal to angle CAT, bad cat, and angle 2 being equal to angle 2. And do you know why we're allowed to say that? Because of Def Cong. Def Cong! Ah! Great. All right, and then that is what enables us to add them together. All right, on to the next step, and don't forget our Def Cong step is in here, right? Def Cong. Okay, so now step 4, look. I know that BAD plus 2 is equal to angle BAT. So wait a second, angle BAD plus angle 2 is equal to this larger angle. All we're doing here is we're renaming BAD plus angle 2. You would never walk around calling it BAD plus angle 2. That's so embarrassing. You want to call it angle BAT. So whenever we rename something, that's going to be the angle addition postulate. So the angle addition postulate and the segment addition postulate are going to be when we rename, and that's a really important concept. All right, on to the next one. And this is our last step. So look here. I know that I've got BAT being congruent to CAD. This is the final step in my proof, so I know that I'm done here. This is my last step. But I've got to figure out why I'm able to say that. So if you look at everything that we've done, we've said, okay, BAT is congruent to CAT. And then I know that BAD plus 2 is equal to CAT plus 2, okay, because we added that on. But now look, I've got BAD plus 2 is equal to BAT. And then I've got CA2 is equal to CAD. So look what happened here. I've got my conductor, I've got my caboose, and look at the train. Ready? BAT is BAD plus 2. BAD plus 2 is CAT plus 2. And CAT plus 2 is CAD. Choo choo. It's kind of messy, but we've got an A equals B, a B equals C, a C equals D, a D equals E. So then I know A equals E. So the final step here is going to be trans. That's the transitive property. That is it. I know that seemed like a lot, but we're going to do more discussions in class and more practice. And this, you're going to go back and look at this proof and be like, this is so easy. This is so crazy. So great job. I will see you soon, and go take a stab at the homework. Talk to you soon. Bye.